All right, I'm back. So let's go ahead and find the derivative of f of x equals the square root of x. So this is going to be the limit as h approaches 0 of the square root of, remember we're putting this inside, so that's going to be x plus h minus f of x. So I'm just literally going to take this right here. That's my f of x. I'm going to write it down. Square root of x all over h. Now, this should remind you of something we've done before. We're going to multiply by the conjugate. So that conjugate looks like the exact same thing as our numerator, except we're going to have, instead of a minus, we're going to have a plus. All right, now we're going to multiply through, and you should know that if we have conjugates, we only have to multiply the f and the l, the first and the last, because that outer and that inner, those two middle terms, they always cancel. So this is going to leave me with the limit as h approaches 0. So if I do this times this, I simply get x plus h, because our square roots undo each other because we're squaring a square root. And then my outer is going to be a minus times a plus, so that's going to give me a minus, and the square root of x times the square root of x is the square root of x squared. Again, that undoes itself, and we're just left with an x. All right, and in the denominator, we have an h and a square root of x plus h, and a plus root x. And just as a reminder, we don't multiply through when it's not going to help us. Well, what happens here in the numerator? Well, our x and our minus x disappear. And then we have an h in the numerator and an h in the denominator, and those are going to cancel. So that's going to leave us with what? Well, you guys always kind of get confused on this, but know that there is something in the numerator, and that's a 1. And then our denominator is just going to be that square root of x plus h plus the root of x. Now remember, we're going to take this 0 now and plug in. So that's going to give me 1 over the square root of x plus the square root of x. And that's going to give me 1 over 2 root x, which is equal to 1/2, and then 1 over the square root of x. Well, I'm not crazy about writing 1 over the square root of x. And so instead, for now, I want to think of that as bringing that up to the numerator. So what happens when I do that? Well, I'm going to rewrite this as 1/2 times 1 over x to the 1/2. Sorry, that's too small. Let me rewrite that. We should all know that the square root of x is the same thing as having x to the 1/2. But if I want to bring that up to the numerator, now that's going to be equal to 1/2 times x to the negative 1/2. And so we could write that just like that if you'd like. And we will come back to this problem. We'll be able to do this problem in about 2 seconds later, but for now we're doing it this method. All right, next one is we're going to find the derivative of f of x equals 1/2 x squared. And maybe you're starting to see a pattern, I don't know. But f prime of x here, I know the answer is going to be just x. And let's see if that's true. I'm hoping it is, cross my fingers. So I'm going to have f prime of x is equal to the limit as h approaches 0. I'm plugging in x plus h, so I get 1/2 x plus h quantity squared minus 1/2 x squared all over h. So now I'm going to do this FOIL in my head. So that's going to be a 1/2 x squared plus 2xh plus h squared minus 1/2 rut row. I ran out of room, you guys. 1/2 x squared did it all over h. All right, I'm going to multiply that 1/2 for each 3 of those terms, and that's going to give me the limit as h approaches 0 of 1/2 x squared. Well, 2 times a half is just 1, so that's just going to be xh plus 1/2 h squared minus 1/2 x squared all over h. Well, what happens to a 1/2 x squared and a minus 1/2 x squared? Well, they disappear. And now I'm going to pull out an h. So this is going to be an h and then an x plus 1/2 h all over h. The h's disappear. So I'm really just left with the limit as h approaches 0 of x plus 1/2 h. Now I can plug in this 0. So that gives me x plus 1/2 times 0, which is just going to give me x. So that is my answer for f prime of x. And I knew it from the beginning, and I'm wondering on this homework as you start to look, what is the faster way to do it? Are you able to see that? All right, so what does this mean? Well, what is f prime of 0? Well, that means just plug 0 into x and you get f prime of x is 0. What's f prime of 2? Again, take 2 and plug it in for x. You get 2. F prime of -1 is -1. F prime of 7 is 7. I think you get the idea. And so what this means in terms of the graph is, what is the slope of the curve at x equals 0? At x equals 0, what's the slope of my tangent line? Up, it's 0. Correct? All right, what about at the point x equals 2 right here? Well, it looks like the slope of that tangent line is supposed to be 2. So that'll be up 2 over 1, down 2 over 1. Does that look right? It certainly does to me. Let's try another one. What about f prime of -1 equals -1? So that would be right here. What's the slope of that? That would be down 1 over 1, so something like that. So that's got a slope of -1 as well. So it works, right? We're just basically saying that the derivative gives us an equation that can find the slope of the tangent line for any x value that we choose to plug into the derivative. So all we have to do is plug our x value into our derivative function and it tells us the slope of the tangent line at that point. Thanks for watching, everyone. Have a joyous day.